of a surface. It is the force acting normally per unit area of a surface. So if we have a surface, we have a surface like this, which is the area, and we have this force, which is acting on this area. This force, for it to be considered pressure, this area is supposed to be 1 meter squared, and this force is supposed to act at right angle. It's supposed to act at right angle. When we talk of right angle, we mean at 90 degrees, as you see this arrow, at 90 degrees. So the force acting normally of anything is what we call to be pressure. Good. From here, from this formula, pressure equals the force over area, somebody can even come up with the SI unit of pressure. Who can give us the SI unit of pressure? Jerry-Lo. Jerry-Lo? Hello, Jerry-Lo? Can you hear me, Jerry-Lo?
Yes, sir.
From this formula, can you get for us the SI unit of pressure? Okay. Let's get from another person. Ashley. Okay, Ashley.
Me, teacher.
Give us the answer. If you have any question, you
SI unit of pressure is.
I want to give you very good. Is what?
Teacher, it's pascals.
The SI unit of pressure is Pascal.
Daniel, can you hear me? Teacher Daniel? Teacher Daniel?
Yes.
There is too much echoes coming from your background. If you can work on your sound, please. It will be so grateful.
Okay, please. Let me work on the echo. I'm in a room where there's too much echo. Let me try to work on it. And I see.
Yes.
Let me hope it has been reduced.
Somehow better now. Thank you.
More better. Good. I was telling you that you raise up your hand in case you have any question.
Wonderful. Thank you.
Thank you so much, Charles, for that correction. So in case you have any question, there's an option for raising up the hands. You go to action. When you get to action, you raise up your hand and I see you. Thank you so much, the person who gave us the SI unit of pressure. It is called Pascal. I see Karen Ojirot. You have a question? You want also to give us another unit? Karen, you have been granted a chance.
Newtons per meter.
Very good. Karen Ojirot. It is newtons per meter squared. Because the SI unit of pressure, force is newtons. That of area is meters squared. And so we expect newtons per meter squared. Very good. Let me clap for you. Do you hear the clap? Good. So we are saying that. Good. The SI unit of pressure is either newtons per squared meter or Pascal, just like how you gave it to us. So just like any other physical constants or physical quantities, which have different units also. Pressure also do have other units. We know the unit of length is meters. They say unit of length is meters. But length can be measured in millimeters, can be measured in kilometers, can be measured in decameter, can be measured in hectometer, and so forth. Pressure, the unit is newtons per meter squared or pascal, but it can also be measured in what? Who can give us that? Rotatuero. Rotatuero, can you give us other units? Okay, the other unit is here. Jerry Roy, can you read for us that unit? Jerry Roy?
Centimeter of mercury.
Very good. It is either in centimeters of mercury or millimeters of mercury. What is in the bracket is the SI unit only. The SI, I mean the symbol. Centimeters of mercury and millimeters of mercury. Please don't forget the standard unit, the system international unit is newtons per meter squared or what? Pascal. But other units are centimeters of mercury and millimeters of mercury. Is there anyone with a question at that point? If there is no question, let's go to the definition of the SI unit of pressure. Good. If there's no question, let's go to the definition
About
of
kilopascal.
kilopascal. Good. Kilopascal is there, but for kilopascal is like some bigger quantity. It's a bigger pascal. It's like if I say kilogram. Kilogram has a gram. So kilogram having a gram, in 1 gram, I mean in 1 kilogram, there are 1,000 what? Grams. But that one does not make it to be a unit. It is a bigger, if the value is too big, then we can start expressing in terms of kilo, mega. You hear that?
Excuse me, sir.
Yes, please.
Excuse me, sir.
Yes, you're excused. You ask the question.
Excuse me, sir.
Okay, please, I'm hearing. You're excused.
Excuse me, sir.
Yes.
I'm not getting to where.
Sorry. Sorry. Who is asking the question?
She said she's not getting you well.
That she's not getting me well.
Yes.
Is it the same case with others?
No.
No.
No. Maybe the problem is with the network. We are very sorry for that. But somebody had asked the question. Yes, Karen Okiriot, I see your hands up. Or it was the other hand.
About kilonewton per square meter.
Kilonewtons per square meter. Kilonewtons per square meter. That one would exist also as long as we are asking or as long as we are getting it in bigger quantity. But in most cases, the most commonest one, we have kilopascal. When you hear kilopascal, that means that there are 1,000 pascals there. Okay?
Excuse me.
Yes, please.
I think atmosphere is also included.
Another unit. Very good. They denote it with the atom. That is atmosphere. We are also going to look at that when it comes to atmospheric pressure. So, I Allow me to move to the next thing if there's no more question under that.
Teacher Daniel,
Yes, please.
learners, can you stop writing on the screen? Can you give opportunity to the teacher to explain very well? Please kindly stop that and focus.
Okay. Good. So we are saying we are going to define now the SI unit of pressure. And remember we said the SI unit of pressure is pascal. So allow us define what pascal is. Pascal, which is pressure. Remember, Pascal is a scientist who is behind pressure, who is behind the theory of what is pressure. So Pascal is defined as the pressure exerted. Okay, it is the pressure which is exerted when a force of 1 Newton, acts normally on an area of 1 meter squared. Very good. So it is a force. It is a pressure. Let me go back to the other slide. Do you see this? Pressure is the force over area, and the unit is pascal. So you're saying that when you're talking about pascal, pascal is the pressure. It is this pressure exerted when this force is 1 Newton. And when this force of 1 Newton acts on an area of 1 meter squared. Is that clear?
Yes.
Good. When I bring for you a test, make sure you write for me exactly the way I've given it to you. So that is the definition of pascal. Now, we have said that pressure is given by force over area. So if pressure is force over area.
Excuse me, teacher.
Yes, please.
The definition of pascal.
Sorry?
The definition of a pascal. Can you put the definition of pascal? The screen.
The definition of pascal, we said pascal is the pressure exerted. Okay, are you seeing it?
Yes.
Is the pressure exerted when a force of 1 Newton acts normally. Please, the word normally is very important. You don't need to leave it out. If you don't talk about normally, we are going to see another physical quantity in physics, which is called Young's modulus. It's also in newtons per meter squared. Though it is defined as stress over strain, but somebody can also say that it is force acting on a unit area. So we want this normally to come out clearly. So the force exerted normally is the pressure exerted when the force of 1 Newton acts normally on an area of 1 meter squared. Is that clear?
Yes.
Good. Let's go to something else. Please, in case you have any question, don't hesitate. We are here together. We are discussing together. We want to benefit all of us. Don't think it is for a particular person, but it's for you specifically. And when I'm teaching, I want everybody to participate. And for that case, Sahi, let me ask you a question, Sahi Adjule. Sahi Adjule, do you hear me?
Yes.
Sahi Adjule, what
Yes.
have you got from so far what I've talked, what I've said?
Pardon?
What have you got so far from what we have seen? If somebody asks you, Sahi, today you studied the physics. Can you tell us briefly what you studied? Yes, Sahi. Hello, Sahi.
Yes. Yes, I'm getting you now.
Can you tell us exactly what you have picked from what we just said? Okay. We can't hear from her. Doris?
Yes,
Doris,
teacher.
can you say something on what you have just
Yes,
seen
teacher.
now? Can you say something on what you have just seen now?
I've gotten the definition of pressure,
Uh-huh.
which is force acting normally per unit area or by surface. Then
Very good.
okay, how to find pressure?
Uh-huh.
Pressure equals force over area.
Well, Bale, thank you so much. Even if you stop from there, is enough. Good. Let us go to the calculation, okay? Let us go to the calculation bit of it. Calculation number 1. It says a box of mass 6 kilograms rests on a horizontal surface. If the area of contact between the surface and the box is is 32 centimeters squared, calculate the pressure on the surface exerted on the surface by the box. Do we all see that?
Yes.
Very good. So we have a mass, a box of mass, 6 kilograms. It is resting on the horizontal surface. Now, the way you are seated, I guess you are seated now, okay? So, where you are seated, if that wood, let's say that wood, I don't know whether you're seated on wood or on the metal, but if it was not strong enough, it would break. What causes it to break? It means that there is some force which is being applied. So in senior 1, we saw that when you sit on something or when there's something supporting you freely, then there's always that force that you exert on that object that supports you freely, and that force is called weight. Okay? So much as you are seated on the table, on the chair, on anything, you're exerting there a force, which is called the weight. That's one. Two, what I want us to know here is, in any calculation of physics, all physical quantities must be, it is a must be in standard units. So if you're doing this calculation, we have to make sure everything is in standard units. So they want us to calculate the pressure exerted on the surface by the box. So if we are to calculate the pressure, exerted on the surface, we need to know the force, okay? We need to know the force and the and the area. Isn't it that?
Yes.
Because for us to get pressure, we need force and the area. We divide the two, not so? So in this case, we say our solution. We have been given mass as 6 kilograms. Okay? We've been given mass as 6 kilograms. So from this mass, we first get the force. So the force exerted here is given by the weight. Who can give us the formula for getting the weight given the mass?
Mr. Daniel,
Yes?
can you try to first stop sharing and then you share again? Somebody is writing a notation on the screen and it is inconveniencing.
Okay. Let me do that. Good. Okay. Let me share again and I see. Jerry, your hands up.
Learners, please,
Yes.
can you stop annotating on the screen, please? Let the teacher
Jerry?
teach it with freedom. Thank you.
Jerry, I see your hands up. Jerry, you talk.
Acceleration due to gravity.
Sorry, repeat again.
Acceleration due to gravity.
Acceleration due to gravity. Thank you. Thank you. Remember the question was, how do we get the weight once we have the mass? Yes, Irene? Irene?
On weight equals mass times acceleration of gravity.
Very good. Very good. Very good. Irene, tomorrow, you hear me? Tomorrow I have to sponsor you break, okay? Yes, very good. Weight equals to? Weight equals to?
Yes, I'm here. Okay. Mass time.
Weight equals to?
Mass times acceleration
due to gravity. Very good, very good, very good. Do we know the value of acceleration due to gravity? Yes, of course, I know some of you know. Who can give it to us? Can somebody just give it to us from there? Who can give it to us? Kennedy, what's the value of acceleration due to gravity? Kennedy? Kennedy? Okay, let me hear from Joram.
Newtons.
Sorry. I see Ruth. Ruth, you can give us the answer. What's the value of acceleration due to gravity?
10.
Very good. Very good. Too good. 10. Thank you. Thank you. It is 10 meters per second squared. So if we are given the mass, we get the force. The force is the weight, mg. So it will be 10, 6 times 10, which is 60 newtons. Please don't forget to write newtons. So we already have the force as 60 newtons. So what is missing is the area. Even in the question, we already have the area as 32 centimeters squared. But we said if you are to substitute anything, physical quantity in any formula, you need it to be in standard units. So centimeter squared. Centimeter squared is not a standard unit of area. So we convert to the standard unit. So in that case, we'll be converting to meter squared. So when you're converting to meter squared, we shall say also area is given. Area is 32 centimeters squared, but we have to convert it to what? Meter squared. So to do that, you will have area to be equals to 32 divided by 10,000. That one is supposed to be meter squared now. So converting from centimeter squared to meter squared, you divide by 10,000. So we get from pressure equals to force over area That means that our pressure in this case will be force. Remember the value of our force was 60. Divide by area, which is 0.00032. So 60 divided by 0.0032. Who's having a calculator there to give us the answer? Is there someone with a calculator?
Yes.
Press for us. Do you see what's on the screen? 60 divided by 0.0032. What do you get? I was saying that you press for us 60 divided by 0.0032.
Teacher, get 18,750.
18,750. Thank you so much. That would be the pressure that rocks would exert on the surface. Is it clear to everyone?
Yes.
Very good. Very good. Remember, we have exercises which we are going to do, and normally I don't encourage wrong answers. So you make sure you understand very well the examples, so that when you go on the exercises, you find it is like eating porridge. Do you like eating porridge anyway?
Daniel, I'm seeing some hands up, like from Joram, from Ruth, and then from hey, somebody is TechnoSpark. Can you identify yourself? Who is TechnoSpark? Yes.
Yes, Joram?
Yeah.
Joram, unmute yourself and you talk. Joram? Okay, let's hear from Ruth. Yes, Ruth. Hello, Ruth. You unmute yourself and talk. They are not talking. TechnoSpark.
You can move on.
Okay. So I was asking you whether you have got this well. Have you got this well?
Yes, teacher.
Very good, very good. Now, we are going to go to example number 2. Example number 2 is right up there. Example number 2 is just right up there. A force of 10,000 newtons is applied on an area of 2 meters squared. Calculate the pressure exerted on the area. Do we all see that?
Yes.
Good. Elisa? Hello, Elisa? Elisa, do you hear me?
Yes.
Elisa, this question is yours, okay?
Yes.
Can you calculate and give us the answer in 1 minute. Is it okay?
Yes.
Very good. Elisa, thank you so much. Please do it for us. We are waiting for you. In 1 minute, okay? Elisa, let's wait for Elisa. The rest we can also be doing to confirm that the answer he has given us is correct. A force of 10,000 newtons is applied to an area of 2 meters squared. Calculate the pressure exerted on the area. Yes, Elisa, we are waiting for you. Elisa, are you done?
I'm done. Yeah, I'm done.
You are done. You can give us the answer first.
Pressure is equal to force out of force divided by area. The force is 10,000 newtons and the area is 2 meters squared. So we say 10,000 newtons divided by 2 meters squared, and it's equal to 5,000 newtons per meter squared.
Very, very good. Please remind me your name. What is your name?
Karen.
Sorry, current.
Karen.
Oh, current. Oh, Karen, thank you so much. Okay.
Welcome.
I think I've already promised somebody breakfast. For you, I'll promise you maybe lunch, but not tomorrow. Okay, I will tell you the day in the next lesson. Is that okay, Karen?
Yes.
Make sure you remind me in the next lesson that, teacher, remember you told me in the physics lesson that you will give me lunch. Okay? Good.
Yes.
We are waiting for Elisa still. Elisa? 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 Is Elisa around?
Yes, Teacher Daniel.
Yes.
I think time is running out, so you can just read some
Answer is
Thank you.
Your answer is
50 million.
10 million. Okay, Elisa, let's check where you went astray. In our solution, we have the force. We have the force given to us as 10,000 newtons, and we have the area as 2 meters squared. So we shall just say from pressure equals to force divided by the area. Remember, our force is 10,000, okay, which is already in newtons, so there's no need of converting. And our area is 2 meters squared, which is already in meters squared. Here you may be tempted to convert again, just like how we did in the previous example. In the previous example, we did so simply because our area was in centimeters squared. So we had to divide by 10,000 to convert it to meters squared. But here it's already in meters squared. So we just pick and substitute. So pressure will be equal to force divided by the area. So pressure will be force, which is force is 10,000 divided by area, which is 2, you get 5,000 newtons. Elisa, let me hope you have seen where you went wrong. Is that okay?
Yes.
Very good, very good. Make sure you correct it, okay? Physics do not repeat error twice. Is that okay? Let's see question number 3. Question number 3 is about a car. A car of mass 1,200 kilograms stands with each of the 4 tires. You know a car has 4 tires? We are showing that it has single. A car of mass 1,200 kilograms stands with each of the 4 tires on a horizontal ground. If the area of each tire is, are you seeing the unit of this area? The unit is in centimeters squared. So there, we are required to convert to meters squared. Is that clear to everyone?
Yes.
Yes.
Good. Good. So we have a car of mass that stands with each of the 4 tires on the horizontal ground. If the area of each, please check that, the area of each tire is 1,200 centimeters squared, calculate the total pressure it exerts on the ground. So, given, okay, we have the mass already in kilograms. And we have the area of, we have the mass in kilograms already, 1,200. So the car, the fact that it's standing on the ground, it will exert a force on the ground. And that force we said is the same as the what? The weight. So we say the weight equals mg. So it will be 1,200 times 10, which gives us 12,000 newtons. That is just the force. Then we have the area. We have the area of one tire is this one. Do you see this? Do you see this? Do you see my highlight?
Yes.
Yeah, we have the area of one tire, but how many tires are on the ground?
4.
So what will be the total area of contact now? What will be the total area of contact now?
What? 4,800.
Very good. Very good. For sure, this class, the problem is I cannot reach where you are right now. But the day we can be together, trust me, we shall even leave studying and then we talk about other things now. Because it seems you guys are too good to discuss only this. So it will be 4 times 1,200. But don't forget, it will be in what? Centimeters squared. So you have to convert to meters squared. So they say that area of one tire is 1,200 centimeters squared. Is that okay?
Yes.
Good. The area of 4 tires now will be 4 times the area of one tire, which gives us 4,800 centimeters squared. Now, the task at hand is to convert this. To convert this to meters what? Squared. We said when you convert from centimeter squared to meter squared, you divide by how many?
10,000.
Very good. Very good. You divide by 10,000. Very good. Wonderful. Wonderful, wonderful, wonderful. I like this class for sure. I think, do you people know popcorns?
Yes.
Yes. If we are together, I would buy a popcorn for 500 and give each of you the other small one. You get that? I'll give you the other small one, the whole class, 1, 1, 1, 1, 1, 1. Is that? And then we first enjoy it. Is there anyone who enjoys the popcorn there?
No.
What do you enjoy most?
Chicken.
Chicken. It takes long to cook chicken, my friend. So we go for something which is easier to make. Good. Let's convert. We divide that one by 10,000. So we shall have 4800 times 1 divided by 10,000. Don't mind about the steps. So we say now pressure equals to force over area. So that means that our force was 12,000 divided by area, which was 0.48. So it gives us 25,000 newtons per meter squared. Is everything okay?
Yes.
Good, good. If I give you some numbers to try, can you pass them?
Yes.
Yes.
Sure? Are you sure?
Yes.
Okay. Kale.
Yes.
Kale. I'm going to do only one example.
Yes.
Very fast. I will be very fast now. Then I give you some numbers to try for me. Good. A glass block of mass 60 grams exerts a pressure of 1,000 newtons per meter squared on a table on which it is resting, or it rests. Find the area of contact between the glass block and the table. So when you look at this question, they're saying we take G to be 10 meters per second squared, of which we already know that. Even if they are not given it to us, we know it. So we have the mass given to us already. We have the mass as 60 grams, okay? But we have to convert this mass to kilograms. Is that right?
Yes.
So when you're converting to kilograms, you divide by
1,000.
by 1,000. Very, very good.
1,000.
Very, very good. Very, very good. So you divide by 1,000. So we shall say, given the mass, is already 60 grams. So you first convert to kilograms. Which will be 60 divided by 1,000. You get 0.06 kilograms. Then from there, when you know the mass, you get the force straight away. The force is mg. So it will be 0.06 times 10. That is 0.6 newtons. Remember, pressure was already given to us as 1,000 newtons. Was it 1,000 or 10,000? It was 10,000 newtons. The pressure was 1,000 newtons per meter squared. Good. So we already have the force, which is 0.6, and we have pressure as 1,000. So they want the area. Please, do you see here? We have the force already, okay? We have the force already,
Yeah.
and pressure already. So they want the area. Can you fail to get the area? No. What is your answer? Can Can you fail to get the area when we know the pressure and the force?
No.
Very good. We just substitute. So where there is pressure, we substitute 1,000. Where there is area, we substitute where there is force, we substitute 0.6. So we shall say that implies that pressure, which is 1,000, equals to the force, which is 0.6 divided by the area. Then from there, we cross multiply. When you cross multiply, we shall have 1,000 area equals to 0.6. Then to make A this.
You're going too fast.
Oh, sorry. So you're saying, are you okay up to here?
No, I'm lost from the beginning.
From the beginning of this question, okay?
Yes.
Oh, sorry. I wouldn't wish that to happen. So the question is right up here, okay? We have a block of mass, 60 grams, exerted pressure of 1,000 newtons per meter squared. Is that okay?
Yes.
On a table, so they want us to find the area. Is that fine?
Yes.
So given the mass, we have the mass already. When you're given the mass, we can get the force using force equals to mg. Is that fine?
Yes.
But the mass should be in kilograms. Here it is in grams. So we first convert to kilograms. Is that okay?
Yes.
So to convert to kilograms, we divide by
1,000.
Very good. Very good. That's what we have done. We have divided by 1,000. You get 0.086. Is that fine, everyone?
Yes.
Yes.
Good. Now from there, after getting the mass, this mass, we get the force now, okay?
Yes.
We say force equals to m what? M? Very good. Force equals to mg. So we shall say force equals to mg. What's the value of g?
0.06.
0.06, that is m. Then g?
10.
Very good. So when you multiply 0.06 by 10, you get 0.6 Newton. Is that okay, everyone?
Yes.
Yes.
Good. Now, remember, in the question, the pressure was already given to us, okay?
Yes.
Pressure was given to us as 10,000 newtons per meter squared. So, they want us to get the area. Good. So, we say from pressure equals to force over area.
Yeah.
So that means that our pressure is 1,000. Do you see that?
Yes.
Where there is pressure, we substitute 1,000, okay?
Yes.
Where there is force, we substitute 0.6.
6 Newton.
So we shall have 1,000 as 0.6 as the force. Is that okay?
Yes.
Yes.
So our pressure was 1,000, our force was 0.6. This person should meet ourselves with this. Let's meet ourselves. Good. So from here, we cross multiply. Is that okay?
Yes.
So we shall have 1,000 times A. What is 1,000 times A?
1,000 A.
Very good. Equals to 0.6. Is that fine?
Yes.
Yes.
Good. So 1,000 A equals to 0.6. So if I want A, what do I do?
Divide.
Multiply 1,000. Divide
Divide 1,008. Both sides.
Very good, very good, very good, very good, very good. So I'm dividing all through by 1,000, 1,000. So when I divide that, what do I get?
0.0006.
0.0006. Thank you, thank you, thank you. Meters squared. Thank you, thank you, thank you. Okay, is there anyone with any question? Is there anyone with any question?
No.
If I give you the number now, can you do them?
Yes.
Can you pass them?
Yes.
Very good. Get a pen and a book and write question number 1. Is that okay?
Yes.
I want the answers before the next lesson. Question number 1. Are you seeing the question?
Yes.
I'm giving you only one minute to copy one question, okay? Okay.
I'm done, teacher.
Very good. Remember, if the length is given and the width is also given, you get the area from length times width, okay?
Yes.
Yeah. I want to hear another person to saying that is done.
And
I'm done, teacher.
Very good. Copy question number 2. Good. Wait, question number 2. Copy question number 2. When you're done, you tell me that I'm done.
I'm done, teacher.
Good. Let's wait for another person.
I'm done, teacher.
I'm done, teacher.
We are done.
Oh, good. The class is nice.
There's your question.
You people are too good. You are too good. Endeavor not to miss the next lesson, please. I don't want to miss you people in the next lesson. Make sure you are there. Study the timetable very well. Okay? But make sure you have the exercise done. Okay. Question number 3. Let's do it very fast. You copy the question very fast.
I'm done.
Tell me that very good. Let me hear from another person.
Teacher, I'm done.
Done, teacher.
Oh, good. Good. Oh, let's see the last question. Question number 4.
I'm done.
Good. Let's wait for others.
I'm done, teacher.
You're done also. Good.
Teacher, me too, I'm done.
Oh, that's great.
I'm done, teacher.
Oh, good.
I'm also done, teacher.
Oh, let me wait for the last person.
I'm done, teacher.
Oh, good.
Teacher Daniel.
Good.
Teacher Daniel.
Yes, please.
Thank you for the good work, man. Can I ask
Teacher, I'm not finished the
Karen, can
question.
you pray for us?
Sorry, somebody not
Before we
finished.
start our session with a prayer.
Yes, teacher.
Yes, you can
Yes.
pray for us.
Mr. Charles, somebody not finished. The person who did not complete the question, you can copy this. Done.
I'm done.
Okay, please. Thank you so much for listening to my presentation. Let's keep always tuned and let's endeavor to always attend the lessons, okay?
Yes, sir.
Be good learners at home, elect parents, always obey them, and that's when they will love you back. Is that okay?
Karen can pray for
Me,
us.
teacher.
Karen, can you
Okay,
pray
let me
for us?
pray. Let's pray. Let's pray.
Baby, you have. You have.
For the lesson that we have. Thank you for all that we have learned. And thank you for enabling us to attend those we have not enabled to attend you. Lay your hand of provision upon them and may they be able to attend. Thank you for the teachers the teacher that has taught us. May you bless him, may you increase his knowledge. Let him give us a great word.
I was saying that you are in.
Hello?
Hello.
Amen.
Thank you. Thank you for the prayer. Thank you so much. We have come to the end of the lesson. Next time when we meet, we shall discuss maximum and minimum pressure alongside the factors which affect pressure in solid. For now, you can say bye-bye to us as you leave the class.